the ground shake.
So the first loop would have to reset the infinity. Would have to reset the minimum value, since we'll be editing the minimum value in this algorithm for each and every node. Remember, in the video, we kept changing the infinity to, for example, 15 in this case, to 15 in this case too, and so on and so forth. We start with infinities, and we have to start with infinity with each and every node. So I'll be restarting it for every node. The minimum value would be infinity, which means this node is unreachable until otherwise proved. So if now we are actually branching from the node, we are trying to see the distances around. So a distance of I, if it's reachable, if the distance is less than infinity and it is visited. Actually, am I using 4 nines or am I using 3 nines? This is important. I'm using 4 nines, so let's stick with that. So if the distance is less than infinity, which means IE is reachable and was never visited, which means I was not equal to 1. So if reachable and never visited, then let's actually visit it. So the next node would be this, since I need to visit it, and the minimum for this node would be its distance. So since we're done with this loop, let's actually have another nested loop in the main big loop that goes for all the nodes. So the other loop now would first, let's first mark it as visited and have the other loop set up for it. So if never visited, let's see the distance to get to it, to get to its neighbors. So next node I is less than the distance to get to I, then let's update the distance of I to be the shorter path. And just to make sure which path did we take, I would say that the pre-visited
node that I actually visited before coming to you was this node.
I'm visiting right now, which is the next node, or it is named as the next node. However, it is the currently visited node that I am on right now, and I just used to get to you. So I'd save it in the pre-D to actually be able to output the path when I'm at the output phase. So now let's exit all loops and start our output phase, where we would actually have more loops just to output all the data we got back to the user. So system.out.println, actually let's make it a print, and plus the distance. So right now we are outputting the distances, the shortest distances to all nodes, and then let's actually print the paths. What am I doing? Okay, for int j, oh okay, for int I is less than 8, I x plus we'd have a string s. String s would be car of num, like num to car, easy, I, and system.out dot print path is equal to plus s, and then j is equal to I. Not to ruin the flow of the loop, we have to loop 8 times to make sure we got to all the nodes, and if I not equal to 0, we would only then run the whole thing. And how are we going to do this? Okay, I know it's j is equal to 3d of j, and s would be num to car, easy, of j. Then we just output it. You would actually understand this when the output, when we output data. I would also first have to write okay, while j not equal to 0, let's actually just print a new line there, so to tell the program we're done. Okay, makes sense. So public static, that would return a string, and that is int I. It's actually easy. It's literally a one-liner. Return I less than 25. I greater than -1. If true, if it's in the range from 0 to 25, we would then return a string value of a character of I plus 65, which will get us to a capital A in the ASCII table. If I recall correctly. So yeah, there is the ASCII table. We are currently at like 0, for example. If we add 65, that would be A, so we're representing A as 0 in our program. We're representing 7 plus 65, that's 72 as H, and so on and so forth. You got the idea. We are first doing it as a character, overcasting, and then we'd get it as a string to make life easier, and if it's false, we turn null. Pretty much that's everything. There would be a ton of compilation errors. Probably there would be a ton of other errors. This is the graph I used in the video. I actually just invented that graph on the spot. I just came up with it. If you don't really understand how did I convert it to text, so let's have a close look. So A has only 3 arrows coming out of it, so that's A, and that's the row of A. 105 would take us to G, so 105 would take us to G, 25 would take us to B, 85 would take us to D. The very first one, A, would take us to A using 0 points, and other than that would be infinities. However, since I'm representing it, representing everything as zeros, as we saw in the code, it actually handled the 0 thingy. So yeah, that's it. So let's actually try and run the code. Cross our fingers, hope for the best. Yep. So let's have a close look here. We can get to B with 25 from A. We can get to C from F using 40 points. However, we can get to F from B, and that would cost us 15 from B. We can get to B from A with 25, so we can get to B with 40, and another 40 to get to F. Another 40 from F to get to C, and C would be 80. A, B, C, okay, D would be 80. F, we can get to F 40. From F we can add 15 and get to C. We can add 40 and get to D. E is infinity. F we can get to using 15 from B, and B is 25 from A, so that's a 40. We can get to G from using 105 from A, and we can get to H using 20 from C. C costed us 55, so 55 plus 20, that's a 75. We can get to G from A directly, and we can get to H. From C. Yep, So we're getting the same results right here. I would like though to explain what was going on in the end. Pretty much this is where everything is happening. At every location we are saving the point we came from. So for example, if you put in 1, which is a B, location 1 in the predetermined array has a 0. Location 2 has the F representation, which is 1, 2, 3, 4, 5, and so on and so forth. So let's take the C input for example. So C is represented in as a 2. So when I hits 2, we print path equals C, this part. And then we would get the entry in the location 2 in the predetermined array, and that would have a 5 inside. We would then print the 5, which is an F, and get back, as we have a little loop right here that would end at 0 at the source node, and this is why we see A at the end of every path, since this was the source node. So we would then enter a 5 and see how did we actually get to F, which is this part. So we got to F from B. So the entry in the location number 5 in predetermined array is actually a 1, and then the location 1 stores a 0. So 5, 1, 0. And this is the exact path we get to F. And since we got from F to C, we would just display C and then the whole path we used to get to F. I would encourage you to, I would actually paste the code down there. I would encourage you to use your own IDE. I would recommend Eclipse, for example. Put some breakpoints, have a look at the data structures, have a look at the arrays and the matrices, see what are they storing in each and every step, and have a closer look at the loops in the Dijkstra's algorithm phase. The code is pretty simple. We have the declaration, the input, the DJ or Dijkstra's algorithm, and the output. Where action happens is the Dijkstra's algorithm. It's pretty simple. You update the distances and then you visit the lowest node with the minimum distance, and then you start updating the distances from there. And pretty much that's all. You can even remove the predetermined thing. That's only for explanation. That's more headache for explanation purposes. If you're coding it to solve a question or something, it would be literally half of this code, and things would be really easy to determine, and that would be your output. Lovely, clean, and I guess it would have like 60 lines or something. If you still didn't understand it, please leave a comment. I would do my best and try to actually explain it one more time in a different way. That's all for today, and see you in another video.